So, print line.
Wait, okay. Send me the assignment.
Yep. And notice there's no due date on that because for the first couple I'm going to be fairly lax on figuring out their due dates. So, I'll also be uploading another assignment that's similar to this one to give you guys some more practice on print lines. Because what was the issue you ran into with the text? You couldn't print out a double quotation mark, right? Right? You couldn't use double quotation marks, right? We were doing print lines, right? And the issue was, right? If you wanted to like say, hey, this is, if you wanted to quote something, right? Single quotation mark was fine. But if I wanted to type something like Linus Torvalds' primary contribution is the Linux kernel, he also created Git. Like if I wanted to do something like a program called Git, I run into a bit of an issue, and that has to deal with what we're dealing with here. So these on my computer it's green. That's just how it syntax highlights, right? This is the advantage of using something like an IDE. It highlights things for you and puts in this thing. System.out.println prints what we call strings. What are strings? They are strings of text. They are strings of characters. They're a bunch of characters just strung together into one thing or another. Now, strings are fairly, they're pretty much any character. Here I've got English, but there's nothing stopping me from if I, if I do this, if I, let's see. If I do right, there's nothing stopping me from putting a Japanese character inside of a string and then going to print it out. So here we go, and as you can see, I printed out a non-English character in there. Strings can take pretty much almost any modern programming language doesn't care about just using. It used to be a problem where basically only English characters could be used, only standard English letters, but that's a bit of an issue because, as you know, there's other languages than English. So, and computers have become much better at being able to deal with these kind of things later. But so we can put any kind of text in there, right? But the issue is that sometimes there's text that we want to print out that we can't print out, like the this quotation mark, right? For instance, if I wanted to print out, he said hello, right? He said hello. Morosely. Let's go with sadly. He said hello sadly, right? This isn't, I've got quotation marks. This would make sense in English that basically what you'd want to say is in the quotation marks, but here I've got an issue. So the way strings work is that we look for a quotation mark as the beginning of a string and at the end of the string. So when you see a quotation mark, you know a string begins, and if you're inside of a string, once you see another quotation mark, you know it ends. Very simple. Except the issue is that with the simplicity comes with the issue of what happens if I want to print out a quotation mark. Well, in almost all programming languages, we use something called a escape character to handle this. So if I want to print out a literal quotation mark, I have to do something called an escape sequence, which means I print out I use backslash, do a quotation mark, and then the next character outside that I want it to be interpreted differently. So now, if I run this, notice I run this, and it says, he said hello sadly. Well, let's change this to gladly, because now it's working. Right? And notice it prints out without those slashes. Now, what else can I do with these slashes? Well, I can do a /n for new line character. although it doesn't really show up there. So, right, if I wanted to do a new line character, then literally this has an issue, right? Where basically, here, let me just show you. If I wanted to put an enter between these things to like print it out on different lines, it breaks it up because Java interprets the end of a line as an end of a thought, typically, so don't really want to do, so it has some issues dealing with that. So what if I want to put each word on its own line and I don't want to put them all in a different print line statement? Well, I can do this. I can do /n, right? Slash means the next character, don't interpret it literally. It's a special sequence. So for here, /quotation mark means I want a quotation character. /n/n, and here it will put a he said. Now, why is there a space after before said? Well, because I told it to be a space before said. Remember, so the computer is going to do exactly what I tell it to do. It prints out HE space new line, the enter key, space SAID space new line quotation mark. Well, sorry, space quotation mark, right? So it's doing the spaces exactly where I tell it to go, right? So if I remove a lot of these spaces, makes it a bit harder to read, but you'll get the point across. He said hello, and then if I put a space here, gladly. So the end result is that I can use /n to split up lines like that. What else can I do with these escape characters? Well, I can do I can use tabs to split stuff up evenly, right? 1, 2, /t to do tabs, and that will separate stuff with a tab character. And of course, if I want to do, now here's the last bit, A, B, C, D, E, F, G, right? If I wanted to do a backslash and print out an actual backslash, I can't just put backslash there because backslash says I'm beginning an escape sequence, right? So it says, well, what do you want to do? So in order to print out an actual backslash, you need 2 backslashes to do that. Now you might be asking, why in the world would I ever want to print out a backslash? And the answer is for the assignment that you're definitely going to be doing at home. That's going to build off of what you've just done. So assignments. So there's something called ASCII art. So the purpose. You hate doing ASCII art?
I don't think I did in the class, but I can just see how difficult it is.
Well, it's not that hard. The idea is that we want you to write a Java program, which when run produces a pretty nice drawing, right? For example, to produce this drawing of cars, of what Dr. Fiore, who provided this, calls the world's lamest car. Here's the source code. Here's all the print line statements we would use for it. You've got this print line statement and this print line statement. And notice for these slashes over here, we have 2 slashes over here, right? To do 1 slash, we have 2 backslashes over here because you can't print them out literally. So this is an assignment we'll do twice. Once we're going to do with some basic stuff. You can draw basically line by line. Other things, though, you can just do, we'll learn to use with, whatchamacallit. When we'll go over it, we'll do it again when we learn about for loops. And ASCII art is nice. It's useful because before we had the ability to like put images anywhere, we would use ASCII art to do stuff. Like here's typewriter style lettering, hello world. You could use it to create weird emoji before emoji were a thing, like the table throw emoji, right? The flipping everybody remember the flipping table, right? That's like a variation of ASCII art. Using these pixelated characters over here to be able to create signatures, right? Here's a bunny, I think, right? So I mean, ASCII art is fairly good, and it's not exactly something that's limited to computers, as this document points out. Here is a 9th century manuscript done with lettering, right? It's a constellation, and they've got lettering in the constellation, right? So this kind of thing has been on, been around since before sliced bread was a thing, right? So it's a lot of fun to try it out. And and this assignment, when I post it online, your objective is to just print out something that's pretty nice. That's a nice drawing. And the 2 students who produce the thing that I think is the nice looking, you'll get 3 extra credit points for that assignment. So not much, but there's a lot of different things. Yeah, emoticons. Yeah, so as you can see, there's been a lot of, a lot of the Japanese users took advantage of their expanded character set to produce much more interesting things. So, as you can see, this easily just builds off of what we already know. Okay, so see, so really that's what we can do. We can format code using escape sequences, right? You can produce a new line, a tab, a double quotation, a backslash. A big also important thing is that Java code requires some amount of spacing, right? We can't just create public class goodbye, right? Like this. This isn't a valid program, right? You need spaces in between your words. But other spaces are pretty much optional, right? This doesn't have any indentation in it. It's not like organized clearly like my code was. But you want to do that. You want to make your code easy to read. Oh, the new lines are optional too, so we could do it on all on one line, but you shouldn't do that either because it's hard to read. All right, so let's go ahead and move on to the next chapter now that we've got the basic stuff. Now that you've got a program working, okay, and refer to the exercise at the end of this chapter 1 to go to do so. So now we're going to learn about essentially Java being used as, or any programming language being used as essentially an extremely powerful calculator. Okay, so let's go to new. So open recent. Let's go into my classroom code, this window, and I'll have to reorganize stuff. Project, classroom, intro, code, new operators. Okay. Oops, that's not what I wanted to do. New package. So I organize my code into packages just to keep things organized. So Java class, and then it's there. We'll go over okay. Class types. All right. So here I'm going to I've created a main program that I'll start teaching you some of the stuff about Java. So we can print out stuff other than strings. Right here, we've just been working with printing out strings so far. Hello, right? Boom, I'm running it, and it says hello. Nothing too exciting there. But I can print out stuff other than strings, right? I can print out 1, right? The number 1, okay? Without quotation marks. Okay, and that's a bit different, and as we're about to see, that's different than 1 in quotation marks, even though it doesn't really appear to be that way on my output. The difference is that 1 is one type of data, and 1 is another type of data, right? Computers deal with data all the time, and data comes in many different forms.
So you opened up a new one now?
Yep, I did, and I will post this code online and this video online. It will be in the linked class code. You'll be able to find all this stuff on after I do it. You'll be able to find it online.
So we don't make a new one now?
You can if you want to. If you want to, it depends on how you want to follow along or not. So, or you can do it in your current in your current window. So, okay. So we can print out, so we've got system.out.println 1, and then we've got system.out.println the number 1, which is a bit different. Even though it doesn't seem to be any different, right? These two both look like 1s over here. So data in Java comes in many, many, many different forms, but they're broadly organized into two types of forms. You've got what are called primitives, and you've got what are called objects. Okay? So to begin, and in the beginning of this class, actually for a great deal of this class, what we're going to deal with only a very few set of number of objects. We're going to be dealing with strings to begin with, scanners, and maybe files. But objects are essentially complicated things that do other things, whereas primitives are just pieces of data. And objects are typically made up of primitives. So let's introduce our primitives tree for you. Since, we deal with numbers all the time. So let's deal with, like, the first type of numbers that we deal with in Java, which are called ints, or integers. 1 plus 3 is equal to 4. So almost everything in Java is what we call an expression. And those get evaluated. Like 1 plus 3, that will get evaluated into 4, right? See how it's a mathematical expression, 1 plus 3. Now, this is an expression that deals with one specific type of data called integers, or ints for short. And we'll be dealing with that for the next, 15 minutes or so. Now, so I can do 1 plus, so I can print out 1 plus 3. I can make these expressions as long as I want to be. So 1 plus 3 plus 4, right? It will evaluate to 8. What other operations can I do? I can do times 2. So it does 1 plus 3 plus 4 times 2, and it gives me 12. Now, why does it give me 12? Because it will be following the rules of PEMDAS. Please excuse my dear Aunt Sally, right?
We wrote that. So it's just an example, so we don't have to actually write.
Right. These are just examples I'm giving you to teach you what integers are, right? But the main thing is that this follows the order of operations that you've learned in math class since forever, right? You do the multiplication first, 4 times 2 to evaluate to 8, and then you do 1 plus 3. If you want to change the order of operations, you change everything around, or you create parentheses, right? So with parentheses, I could say I want to add these things. I want to add a 1 plus 3 plus 4 together, then multiply that by 2. And see how adding parentheses will change that answer for you. So we have your standard operations. You can, let's go ahead and see what we can do with 1 and 2, the most basic numbers we have. We can add 2 numbers, right? 1 plus 2 is equal to 3. We can subtract 2 numbers. 1 minus 2, it's equal to -1, right? No surprise there, right? Okay, so it deals with negative numbers. That's good to know. Okay, you can multiply 2 numbers. 1 times 2 is equal to 2. And of course, right, we can divide 2 numbers. 1 divided by 2 is equal to what? 1/2, right? Right? Well, unfortunately in Java, this is where we first get our first curveball. 1 divided by 2 is equal to 0, because we're back in the 4th grade right now. We're back in elementary school, where computers are, because the programmers who designed this language are stupid. The computer's not stupid. It's doing exactly what it's told. 1 divided by 2 is equal to 0, because we're back and forth, because we're dealing with integers, right? And if you remember, integers, they have no floating point. They have no fraction. It only deals with whole numbers. So it essentially rounds down any decimal place it receives, right? So 1 divided by 2 would be 0.5, but throw away the 0.5, so you're left with 0, right?
So,
0 is, well, you can tell if a number is a floating point number in Java or in any programming pretty easily if it has a floating point. So there's no period in here, so it's an integer. So but excellent question. 1 divided by 2 gives you the integer 0. Now why is this? Well, so there's 2 ways to remember it. Either you throw out the floating point, or Well, I see two integers here, so that means I'm back in the 4th grade where if I do this, 1 divided by 2 is 0, remainder 1, right? That's how you remember learning it like that before we started moving on into decimals. We would do 0, remainder 1, which actually brings me to the magical 5th operator. Modulo. 1 modulo 2. So this is one that believe it or not, you do know, because I just told you what it was. 1 mod 2 gives me 1, which isn't too exciting. Let's go ahead and look at this one. 11 mod 2. So let's look at 11 divided by 2. 11 divided by 2 gives me 5. And let me copy paste the line so we can do this all at once without having to deal this. 11 divided by mod 2 gives me 5. Sorry, 11 divided by 2 gives me 5. 11 mod 2 gives me 1, right? So, right, because 11 divided by 2 in 4th grade is 5 remainder 1, right? So 11 mod 2 gives me 1. So let's look at this with a 3 over here instead. Right? 11 divided by 3, that gives me 3, right? So it gives me 3 remainder 2 because 3 goes into 11 3 times, and I've got 2 left over. And 11 mod 3 gives me 2. So modulo, what it does is it gives me the remainder. It's the remainder operator. Now that doesn't seem that useful, because you really haven't done used to it. But now that you're working with data, it's going to be useful. So 11 divided by 3 gives me the quotient, and 11 mod 3 gives me the remainder. The math isn't hard. It's everything you just learned in 4th grade. It's just we have a new name for it. And we gave it a complicated name from modulo because it has to deal with weird mathematics called modulo, space. And you don't need to know that. All you have to know is that if you do 11 mod 3, it gives you the remainder. Okay? And you might imagine, well, why is this useful? Well, say I've got some super long number, like this, right? And I want to know what the last digit of that number is. Like somebody gives me a number and I don't look at the number, but I just want to know what the last digit is. Well, if I do modulo 10, that number modulo 10, well, it gives me the remainder after it's been divided by 10. And that's always the ones place. So it gives me the last digit of it. So modding something by 10 is a great way to give me the ones place. We can also modulo by 2, as we'll see a lot, to tell whether a number is even or odd. So modulo has a lot of uses that become more and more apparent the longer and longer you continue. But being able to get the remainder is a surprisingly useful tool. So we've got 5 operators that we deal with stuff. We've got plus, minus, multiply, divide, and modulo. Okay. Notice that there's no exponentiation in here. We don't have a power operator here. I mean, we do, but not a basic operator like this, right? Operator, operands, and we use these operators and operands to build expressions which get evaluated, right? This is all algebra that you've all learned at some point, even if it may have been a while. But that's okay. You don't really the most you have to know, about trigonometry in this class is to know that 90 degrees to the right means you turn this way. That is all. That is the most I'm expecting out of your mathematics. Okay. Eventually, and because if I tell you that I need more, you're not gonna, it might scare you, and people underestimate their own mathematical abilities. So, those are integers. Now, what's fun about this, and I'm still dealing with just integers, is that, your calculator can store things in memory. Well, you can do that in Java too, with what we call variables, right? So what we can do is we can create a variable called int x. So there's 2 steps to creating a variable in Java, and we can condense it into one. The first is to declare a variable. So here I've declared a variable called x. This tells Java, please set up space for an integer. but I'd like you to set aside some space on my computer to hold an integer. Now this space will only exist while the program is running. It gets thrown out once the program's done. Okay, and it exists only in your RAM. In other words, the workbench of your computer. So this says just create a space for me, a space on my computer, and this space is going to be given the label X. Imagine your computer is essentially creating a box to put something in. It's shaped. This box is shaped big enough so that you can store an integer in there, and then it puts a nice big shipping label on it that says X, so you can easily identify it. It doesn't know what's in there because we haven't told it what's in there. So now let's put something in there. So here I'm going to say X is equal to 10. And this is kind of a fundamental thing in Java and in programming languages. We'll say this is X is equal to 10, but that's not exactly what happens there. What's happening here is that we're taking the value on the right and we're storing it in the left. We're assigning X the value 10. Okay? And I'll be doing more complicated stuff in the next lecture with this, but for right now, all you need to know is that this is called, we're taking the value on the right and storing it in the left. It's not exactly equals, but we'll be calling it equals. Now, this is because the equals, again, this goes back to programmers being, as you said, dumb, because we are. It's also much more of us being lazy too, because what happened is really what is better going on here is that we've got, is that a better symbol would be saying X with this arrow sign goes, into here. But unfortunately, I don't have an arrow on my keyboard, right? And if I tried to create one using less than my computer will now interpret this as X is less than -5. So that's not going to work, right? Well, what about that? Less than or equal to 5. That's not going to work, right? So, so that's just, as you can see, it's kind of, we're pulling our heads out trying to come up with a good solution here. So a solution in one programming language was to do colon equals, which kind of looks like an arrow if you squint at it in bad lighting, right? And some languages still use this, but use it specially, right? But eventually people just got lazy and said, no, in my programming language, we're just going to use a single equal sign to say we're going to take this thing on the right and put it in and store it in the left, right? Notice that if I do it the other way around, I say 10 is equal to X, it's going to yell at me. I've got a red line over here saying X might not have been initialized, so let's go ahead and say, actually, let's say X is equal to 10, and then 11 is equal to X, right? It's going to yell at me saying, hey, you need to put a variable there. You can't take something and put it in a literal, right? There's a literal being literally a number, right? It's a good name for it. Literally a thing. Okay, so now we can use this in our equation. So we can say 1 plus x, right? We can do this now and copy paste this a bit better. 1 plus x. We can do our minus x times x divided by x, right? And then modulo x, right? So, yes. Oh, I thought that was a question. Sorry. It's fine. No, it's no problem. And now if I wanted to change this up, I can just switch one. What's nice about this, remember, goes back to us being lazy. Switch one number. I can switch this once, and now instead of doing all those operations by 10, I'm doing them by 2. Exactly. And boom. So one change. So I just changed one thing in one place, and it does that.
Wait, wasn't X originally 1?
It was 10 originally.
Oh, I didn't do that.
That's fine.
I only thought it was.
Okay. Now I've got ones on the left. So now so we have 2 steps essentially: declaring a variable and initializing a variable, right? So 2 steps for creating a variable, but like I said, we're lazy, so we can actually condense that into 1 step. Okay. Int x is equal to 2. We can just simply do it in 1 step like that. Okay? So where I'm declaring and initializing it in 1 step. Now, and it's important to understand that there are 2 steps because I can change x's value later on. I can say x is equal to 3, right? And I can prove it to you that it changes to 3, right? By changing that value. And see, it prints out 3 at the end because x value is now 3. Now notice I didn't do int x is equal to 3. You only do the int x the first time because you're declaring the variable, right? That makes sense? So remember, this step is just condensing 2 steps into 1, right? When you say int, you're saying I'd like a new integer x. Okay? So if those are now how big of a number can I store in here? Now in Python, right, that wasn't an issue, right? If you remember, you were in the afternoon, yes? Python wasn't an issue. No? So, sorry, never mind. Python, this isn't an issue. There is a issue. Sorry. So Python, this isn't an issue. In Python, I can make, watch, I'll boot up Python. I can make the number as big as I please, right? Doesn't matter how big the number is. I can make it huge and add 1 to it, and it doesn't care. Python's great like that. Java does care though, because it's drawing on something, an older programming list. So we can store essentially 32 bits of information inside of an integer. Bits being primary digit, being binary digits. I'll go into detail as to what that means, but for right now that means is that there's only so much information you can store in a bit. That means integers go up to about 2 billion positive and about negative 2 billion in the negative direction. 2 billion positive, 2 billion negative. If you need something bigger, if you need a longer integer, we have a 64-bit integer, which we call long, unoriginally. And if you want to create a long integer instead of a short integer, sorry, instead of a regular size integer, you just call it a long instead. Now, we almost never use longs. By the way, so a long is 64 bits. A regular int is 32 bits. So how much would a short be? There is such a thing as a short in Java. So how big would that be? If a long is twice the size, right? So long is 64, int is 32, so it's twice the size. So what should a short be? 16, exactly right. Right, a short would be 16, and that's exactly what it is. So, but everybody just uses ints, so no need to really remember about the longs too much. Longs are 32-bit integers. And they deal with just integers, right? If I tried to store 2.5 into an integer, it's going to scream at me because it says, you can't store 2.5 in an integer. I just store integers. That's my job. That's all I do. Okay? So, what do I do if I want to store floating point numbers? Well, there's a data type, as alluded to, called a float. I think you mentioned it earlier. Yeah, floats. But in Java, floats are small. They're 32 bits. And for floating point, we like to use a lot more space. So our floating point numbers are called doubles. So let's create another thing called, so let's go ahead and say double d is equal to 1.5. So let's go ahead and do system.println 1 plus. So we know if a number is a double if it has a floating point in it. So 1.0 plus 1.5 plus d, that's a floating point number plus a floating point number, right? So 2.5. Okay. Next is to do. So let's go ahead and see. Let's just do the same thing where I did multiplication and division and modulo, right? I did all those operations together, right? And you can do modulo you can do the remainder operation with floating points, which doesn't necessarily make sense, but you rarely do it. So worry too much about it. Now, the important thing to know is that you can mix integers and doubles together in an operation, right? I could do 1 instead of doing 1.0. I could do 1, and I'll still get the same answers. Let's go ahead and add this out. Doubles. And let's go ahead and add ints over here. So run this. So ints doubles, right? The doubles, if I use 1s over here as opposed to 1.0, what happens is that since doubles can hold more data, the integers will be converted to doubles automatically. Okay? That makes sense to everybody? You convert, if you've got an integer and a double, the ints will automatically convert into doubles before you do the operation. That way, if you throw an int into the equation, it will be able to work with it. All right. So the next thing we need to be able to do is, so let's see, what other primitives do we have? We have some other basic types of primitives. There's 2 more types of primitives that we deal with. The first one is called a character, which we rarely work with. Now, characters are single characters, and they are, made up of, but they're the individual elements that make up a string, right? A string is a bunch of characters stuck together. So character C is equal to A. Okay. So if I run this program and I've got a character C, I store A inside my character C. It's car for short because, again, we're lazy. So we want to just use as few letters as possible. So storing A in a character. And again, we're rarely going to use characters. But what's cool about them is that I could do something like A plus 2 plus 3, right? Back to Caesarean cipher that I mentioned in the beginning of class. A plus 3 gives me the letter 3 after A, which gives me D. That's pretty nifty. That's kind of useful. And this is because at the end of the day, characters are just integers. Characters are just another type of integer, right? What we actually have is, notice how I did C plus 3 and it gave me 103. This is because, let me go ahead over here and erase this. This is because the value for A, it's everything, remember, everything in your computer is a bunch of 1s and 0s. They're a bunch of numbers. So how do we know how do we get letters there? And the answer is Unicode, right? And what we've got here is that we've got like a big chart of kind of a thing. So let's look at 0 at basically the beginning of our chart. So here's our table. So 30. Let's see. Oh, this is in decimal. Sorry, this is in hexadecimal. That's base 16. Oh, so let me ASCII, because I don't want to have to teach you binary yet. Next lecture. Here's an ASCII table. So this first number is decimal. So it basically says here we have 7 bits of information. Let's go ahead and if we see a bit combination, which is a binary combination, which gives us 109. Let me zoom in because I realize how tiny it is. That was the opposite of zooming in. So if I see if I see 97, that's going to correspond to an A. Okay. And what initially would happen is like, oh, well, 127 letters are good enough for any alphabet, right? Well, that's not true. That may be true for English. And so then the other countries, they can do what they need to do with the other 128 that go into a single byte. Again, we'll go into what that is later. That obviously wasn't enough, so it led to huge problems. So basically everything supports Unicode these days, which means if I wanted to do something, I can, let's see what will happen if I print out A plus 2481. This should print out some weird random glyph. So yeah, it doesn't actually have a defined value there. What about 2000? What about 250? Should give me something that's defined. So it gives me an S with a little mark on top of it, right? So so characters, though, you aren't going to deal with them individually for the most part. So no need to really worry about them too much. And then the final thing, which are Booleans, they store only true and false values. We'll go into them again. I'm not going to cover them now. I'll cover them when we get into if statements, which will be probably on Thursday. But for right now, the important thing to deal with are characters. Integers and integers and doubles, and our last thing, which is strings. You know what? So as I said, I care about Booleans, but I don't really want to bring them up in class. So Boolean B is equal to true, but I don't care about it. We're going to leave it for later. So I can do something so that my code will, so that my compiler will ignore my code. It's called a comment. So I put / there, and what a comment does is that it essentially my compiler ignores it. My program ignores it. So comments come in two forms. Single line comments. So it says anything that comes after a // I'm just going to ignore for that entire line, right? So if I were to, for instance, here I have ints at the very beginning of this program, right? And so if I comment out this line, it's just going to skip it, right? It doesn't print out ints anymore. It's commented out. So this is useful when you're debugging. Now, if I do this, and the second kind of comment is what we call a multi-line comment. Where we do, and basically it's /* and */ and it says that anything's between the /* and the */ is commented out. Okay? And so those are useful for basically removing blocks of code temporarily without deleting them, which, as you can imagine, if you're just testing a small component of your code, this is a very nice thing to do. Okay. The main purpose of comments is, though, to actually comment your code with actual English for other users, right? Like this. Here are the addition operation. Sorry, here are the operations we can do on integers, right? They help you explain what you're doing. Comments are good. Okay, so I've been talking about strings, but I haven't actually really gotten into them. So let's go ahead. A string is it starts with a capital letter because unlike these things, it's not a primitive. It's more complicated than that. Strings are powerful. So let's call it string word. And we can store basically a word in there. Let's go with literally a word, even though that's two words, right? So a string can be as much text as I want it to be. So I can print it out. So I can print out word, and it will print out a word. Yeah, go ahead. Yeah, if you guys need... Actually, do people need to take a break? Okay, yeah, so let's come back here in like... Yeah, I completely forgot about that aspect. I got way too into it. So let's go ahead and come back in like 5 or 6 minutes. Okay?